Hi, my name is John, and one of my students imposed this question on me, and it was kind of tricky because usually I can answer most of my students' questions in as soon as I read the problem, but this one kind of got really tricky. So after I solved it, I tried to check my answer out, and it didn't quite work out the way I expected. So here's the problem, and it's an exponential growth or decay. It doesn't really matter if it's a growth or decay. It's from page 610 of New Horizon. It's for Calculus BC students only. But if you're an AB student and you want to go into exponential growth or decay, you're welcome to take a look at this video. The question imposes upon me is, suppose that 40% of a certain radioactive substance decays in 5 years. Suppose that 40% of a certain radioactive substance decays in 5 years. I made the assumption decays. So it's not 40% that decayed. It's 40% that decayed. That means 60% is left. That was the first mistake I made. So make sure if it says substance decays, that means since 40% decayed, 60% is left. And we're going to go at time t equals 0, whatever that initial time is. Let's call it P naught, the amount that's left, which is the initial amount. Okay, so P naught, we defined that the initial amount. You can use C naught, whatever you want to use. Okay, at time t equals 5 years, 40% decays, which means 60% is left. Percent of P naught is left. So 0, comma P naught and 5, comma 0.6 P naught. That's your initial information. I also made a little bit of note. If it's growth or decay, we usually use this function dy over dt. That's the instantaneous change of the amount, y, respect to time. It doesn't matter if it's growth or decay. It's always going to be some constant k, we have to figure out what that is, times the growth, y value, how much it's decaying or growing. And it doesn't matter if you put a plus or minus at the end, because these two values will make k either positive or negative. So I tried it both ways. It came out this value is negative. If you put a minus in front, k turns out to be a positive, so it really doesn't matter. Okay? So don't forget, the rate at which the y is changing with respect to time is always some constant of proportionality times the value of y, whatever the amount that's left. And it's always going to be constant for exponential growth or decay. So we try to plug it in. We moved the dt over, we moved the y over, so it becomes dy over y is equal to k times dt, and we take the integral of that. The integral of 1 over y is going to be natural log of y is equal to some k times t plus a constant, and from here we take the exponential of both sides, e to the natural log, cancel that, it's the inverse operation, y is equal to e to the kt, and then e to the constant plus something is going to be e to the constant again. It's going to be a new constant right over here. Don't forget, it's a different constant, but it doesn't matter, it's a constant. E to the constant, call it C naught, times e to the kt. At this stage in time, you can actually plug in 0 for t, or y of 0, and then we should end up with P naught. So that's P naught is your y value. So plug it in here. P naught is equal to some constant, whatever that is, times e to the k times 0. And k times 0 is 0, e to the 0 power is 1, so P naught is equal to C naught. So your equation looks something like this so far. Y equals the initial amount, whatever that initial amount, I defined it right here, times e to the k times t. And now we're going to use this point right over here. That's the decay. And 5 years, it's going to be only 60% of what's left. So plug it in here, you end up with 0.6 times P naught is equal to P naught times e to the k times 5. And so you notice that the P naughts cancel at this stage. Let's write it right here. So 0.6 is equal to e to the 5 times k. And since the variable is at the exponent, we take the natural log to both sides. Natural log of 0.6 is equal to natural log of e to the 5k. Notice the beauty of logs, the exponential comes down. Natural log of 0.6 is equal to 5k times natural log of e. We know that the natural log of e is 1. Solving for k is equal to natural log of 0.6 divided by 5. I believe I have that information right over here. K turns out to be, of course, negative 0.1022. And so part A asks, so let's write it in. Part A asks, what is the half-life? The function looks like this. Y is a function of time. Is equal to P naught, the initial amount, times e to the negative 0.1022 t. When we're looking for the half-life of a substance, this is going to be equal to your 1 over your half-life. 1 over your half-life is going to be negative 0.1022. We know it's going to be a decay right there because of that negative. Your half-life is going to be approximately, and I did this earlier, 9.785 years. I multiplied by the reciprocal, the reciprocal of negative 0.1022 is approximately 9.785 years. That kind of makes sense to a certain respect. Let's go over the question one more time. In 5 years, 60% is left. So a little bit more over 5 years, probably close to 10 years, probably 50% is going to be left. And that makes perfect sense because we should have approximately 50% of left, and it's going to be a little bit more than 5 years, 9.75 years. Part B says, suppose that a certain quantity of this substance is stored in the cave. What percent of it will remain after T years? So the second part gets a little bit tricky. I also made a little bit of a simple error on this, so I'll go over my error with you just to make sure you don't make those same errors. What I did was on part B, percent left. What was the question again? Will remain, percent left is equal to the amount left divided by the total amount. And what I did was I did percent change is equal to your final value minus initial value divided by initial value times 100. I don't know if you remember this from chemistry or not. You did a lot of this. Let's do an example. You started with the initial amount was 10 gram, and your final amount was 12 gram. You increase your value, so your final value is 12 minus 10 divided by initial amount is 10. The difference is 2 over 10, which is equal to times 100, which is going to be 20%. So you increase your value by 20%, but that's not what that question asked me. Excuse me. It says what's the percent left, not the percent change. So it's the amount that's left divided by the total amount, which is your initial amount. So the total amount left is going to be in the function P naught times e to the negative 0.1022 t divided by P naught. That's your initial amount times 100, of course. The P naughts cancel. You end up with 100 e to the negative 0.1022 t. And that's your final answer. And now I check my answer on this one. Let's say at t, CYW, check your work, guys, okay? And we're going to check our work just to make sure it works. I'm going to do this on my calculator on the spot, okay? At time t equals 5 years, we should be left with 60% left. 40% should have decayed, 60% should have been left. So we're going to put a question mark on this. So the percent is going to be 100 times e to the negative 0.1022 times 5. Close my little thing on this one. I don't know if you can see it or not. 100 times e to the 0.1022, 0.10, excuse me, should be negative 0.1022 times 5. The negative, if you don't get that negative in, I didn't get that negative in at the very beginning sometimes, and it threw me off quite a bit. And you should end up with 60%, 59.9895. That's approximately 60%, and so we checked our work, okay? It kind of threw me off at the very beginning again, due to the fact that 40%, I used 40% of P naught is left, and that wasn't the case. I didn't read it correctly, so make sure you read the question properly. The second thing is the total amount, percent that's left is the amount that's left divided by the total amount instead of your percent change. Okay, so that should give you a little bit of help on how to solve these problems out. Good luck on exponential growth and decay. One thing I do want to say, of course, again, is your t value right over here, or k value, excuse me. It did turn out to be negative 0.1022. And if you used this equation as negative in front of the k, then we should actually come up with a positive k value. And so it really doesn't matter if you use the change in output to time is equal to some k times y. The amount is directly proportional to that amount. Or if you go dy dt is equal to negative ky. Doesn't matter which formula you use. These 2 points will actually compensate for your negative or your positive. Good luck, guys.